Hi guys, welcome to my channel, and today we're going to solve some SAT Desmos hacks question. Okay, we're going to start with a factor question. Okay, for the function of f, for every increase of 1/2 in the value of x, the value of fx increases by a factor of c, where c is a constant. Which of the following forms of function f displays the value of c as the base or coefficient? So let's ask which of these displays c as the base or the coefficient, which are these values over here. So what we have to do, I'll just put letter A. You can basically put any options, but I'm gonna choose A, which is at 56 times 2 to the power of 6x. Remember to put fx before that. Okay, for the second equation, the second one in the Desmos, we're gonna have f of a plus 1/2 over f of a. Because in the question it says for every increase of 1/2 in the value of x, the value of fx increased by a factor of c. So in this case, a is gonna increase by 1/2. Okay, after that, we're not gonna have equal sign. We're gonna have the similar to sign, and we have to memorize this in order to apply these Desmos hacks methods. So we're gonna have c, and now it shows us that c is gonna be equal to 8, which will correspond to letter B. Okay, if you guys are asking why I am putting letter A, but it shows that c equals to 8, so I'm just gonna change this into the answer of letter B. Still is gonna show c equals 8, and if it's not convincing, I'm gonna put the other answer choice. Still 8. Still 8. Okay, on to the next question. For an electric field passing through a flat surface perpendicular to it, the electric flux of the electric field through the surface is the product of the electric field strength and the area of the surface. And the certain flat surface consists of two adjacent squares where the side length of the largest square is 3 times the side length of the smaller square. An electric field with a strength of 29 volts per meter passes uniformly through the surface, which is perpendicular to the electric field. If the total electric flux of the electric field through the surface is 4,640 volts times meters, what is the electric flux in volts per meter of the electric field through the larger square? Okay, first we're gonna analyze this question through this Desmos. So we're gonna have 4,640 volts times meter. Okay, now we're gonna have that simple that we gotta memorize, which is the similar to symbol. So firstly we have 29 volts per meter. We're gonna multiply that by the area, which is calculated through 3s squared, which is a larger square, plus s squared, which is a smaller square. So we're gonna have this equation. Next, what we gotta do, we're gonna make the Desmos calculate for us the area of the larger square. We just put 3s squared. We're gonna have the value right away, which is pretty quick and easy. And now the final step it's asking at the final question, the electric flux in volts per meter of the electric field to the largest square. Just take 144 plus 29, and we're gonna have the answer of 4,176. Okay, let's move on with another table question. So we have the table of two x values and their corresponding value of gx, where gx is fx plus 5 over x plus 8, and f is a linear function. What is the y-coordinate of the y-intercept of y equals fx in the xy plane? Okay, this is a very easy question. We just literally put the whole thing in the Desmos like this. So we have x1, which is correspond to x in the question, and y1, which is gx in the question. And we're just simply gonna put the whole equation with a similar to symbol like this. But in this case, for fx, we're gonna put mx1 plus b, because that's slope-intercept equation for fx, and plus 5 over x plus 8 for x1. Gotta make sure that's all x1 and y1. Okay, so we have the answer right here, which is b equals to negative 113, which is the y-coordinate of the y-intercept of the graph of y equals fx. Okay, on to the next question. A quadratic function models the height in feet of an object above the ground in terms of time in seconds after the object was launched. According to the model, the object was launched from a height of 0 feet and reached its maximum height of 1600 feet of 10 seconds after it was launched. Based on the model, what was the height in feet 15 seconds after it was launched? So firstly, we gotta put in the table. So x1, we're gonna have 0. So 0 feet, 0 height. So now we have 0 seconds and 0 height. Now we have 10 seconds, which is the maximum height of 1600 feet, which means it takes 10 seconds to go up its maximum height. So it's gonna take another 10 seconds, which corresponds to 20 seconds, which is 0 feet. Now we're gonna plug in the equation. So we have y1, the regression equation, similar to a times x1 squared plus b x1 plus c. We have all those values in here. It's the maximum height. So we gotta find out what was the height in feet of the object 15 seconds after it was launched. So we're gonna plug in x equals 15. And we're gonna just click over here, which is 1200 feet, which is the answer for this question. Hey guys, today I'll show you guys a very helpful tip to solve a circle question of the SAT. Okay, so we have in the xy plane, the graph of the equation is a circle. The length of the radius of the circle is np, where n and p are positive constant, so it's asking the value of n. So now we gotta find the radius first. So first we gotta put the whole equation in Desmos, which is 8x squared plus 112 px plus 8y squared minus 64 py equals negative 448 p squared. So it's gonna pop up add slider for p. So we have p equals to 1. So we have one value already. So as it says in the question, it says the length of the radius is np. So we gotta find the radius. So now in this graph we have these two axes, and the line between these two axes is the diameter of the circle. So now we will have to put distance, open the bracket, and we have the first axis, which is -7 and 7. We'll just open another one, close it, and then we have -7 and 1. So now we have 6 as our diameter, but what we gotta find is the radius. So we just take 6 divided by 2, which is 3. So now we have 3 as the radius. Now we have NP equals to 3. We have P equals to 1. And now N is gonna be equals to 3. So that's our final answer for the value of N. Okay, thank you guys for watching. Be sure to like and subscribe if you want more Desmos hacks video like this.